two-way tables in probability? Well, if you look at this question, there's an awful lot of information given about 60 children, and you can see that we're told about the activity they choose, and we're also told about whether they are boys or girls. So we're told two things about them, and if we have two things we know about them, or two characteristics, we use a two-way table. Had we not been given two characteristics, but just one, let's say which activity they chose, we'd have used a Venn diagram, and there is a separate tutorial on how to do that. So what are we going to do when we're given this information? Well, the first thing we're going to do is we're going to draw a table and make sure that it has what we call the marginal totals. In other words, as you can see from question 1, a row of totals and a column of totals. That's very important. Okay, sometimes the table will be drawn for you. Fill in the information given, and it should allow you then to calculate all the other figures, and we'll see how we do that in a minute. And then there are the various probability rules that we're going to use. Okay, and we'll use those as and when we need to. So let's look at this question. We're told that there are 60 children, and we can fill that straight in to the total, as it were, because everything's going to add up to 60. Okay, and then we're told that 18 of the 23 children who chose archery were boys. Well, that's actually two pieces of information. We're told that the total number of people who chose archery is 23, and we're told that 18 boys chose archery. So there's two pieces of information. And another two pieces of information are that there are 24 girls, because half of the 24 girls chose curling, so we can put 24 girls, and half of those, which is 12, chose curling. So two more pieces of information there. And then the final piece of information is that 7 boys chose bowls. And so boys choosing bowls is there, and that's 7. Now we've got a lot of information, and we need to calculate the rest of it, because it asks me to complete the table. Now there are always lots of different ways you can do this, but I'm going to go straight for archery to start with. 18 plus what is 23? Answer 5, remembering that those two things must add up to the total. And then I'm going to go and have a look at the girls row. 5 plus 12 plus what equals 24? Well, 5 plus 12 is 17, and so I need another 7 girls to complete that row. So I know that 7 girls did bowls. And now I can just add these two numbers up, the 7 and the 7, to find out how many people did bowls in total. 7 and 7 is 14, and we're getting there. Now looking at the totals along here, 23 did archery, 14 did bowls, there were 60 in total. So what adds up with 23 and 14 to make 60? Well, 23 plus 14 is 37, and so I need another 23 in there. And again, I can now do some adding up, maybe easier than subtracting. Oh, no I can't, I need to do some more subtracting. I need to find the number of boys who did curling. Well, I know that 23 people did curling in total, 11 of them were girls, 12 of them were girls, and so 11 must have been boys, because 11 plus 12 is 23. And then finally, and there'll be two ways of getting this one, if I add those three up, I'll get the number of boys. And 18 plus 7 plus 11 is 36, and you can check that you're right by making sure that 36 plus 24 is 60. Which it is. So, we just lost my 6 there it is. Right, so we've completed the table. Now, what is the probability that a randomly chosen girl chose bowls? Now this is actually a conditional probability, but because we've got a two-way table, we can do this in a much more intuitive sort of way. Okay, so we're looking at the girls, there are 24 of them. What's the probability that one of them chose bowls? Well, there are 7 of those that chose bowls, and so we can say the probability that they chose bowls, given they're a girl, is